This is the last thing we're going to talk about tonight, so if you're looking for a finish line, that's something for you. There's something to look forward to. But you don't want to tune out on this one because you'll be on the hook for the knowledge. Tech assignments are always applications of what we're working on in class. And in stat, if you don't get technology involved, then you're not doing the right thing. You know, not you as a student, just anybody interested in statistics. Right? It's such a critical part of the area, the content area, the area of study, that you're losing all the power of statistics by not incorporating technology. So if you're not a tech person, this is not music to your ears. But in this day and age, you have to get to a point where at least, you can troubleshoot some technological issues. And if not, you can at least find a workaround. Right, so we have the attached file. You can see it's due midnight the day of the first test. Talk about that later. What I just discussed here, what I just discussed is elucidated here. You'll see this little component, and this is true for all technology assignments. It's not a group submission. What that means is that you got to submit your own product, but you're more than welcome to work together. All right. So if you know somebody in the class that you can work with, next time I'm actually going to budget some time for you to break out into groups, and you can share screens and stuff like that, so that you can work on this together. But the idea is that you'll collaborate and share your knowledge, but you'll still turn in your own product. The rubric is very important because there's a lot of ingredients that come into play, but you'll see as you work through the technology assignments that they're all pretty like cut and dried in terms of like, do this, then do that, then do that. All right. So we're going to work on, and this is the to-do list, we're going to create GeoGebra accounts. All right. So this is like a little clearinghouse for mathematical assignments and projects and stuff like that. It also, it has a lot of similarity to Desmos. So if you like Desmos, then maybe you'll like this. If you hate Desmos, then you're gonna hate this just as much. Work through the attached assignment, and the rest is obvious. Get it in on time, participate in all that stuff. All right, so let's go to the assignment. Click on Tech Assignment A, GeoGebra Modeling with Data Online. All right, so again, the important note, this is not a group submission, same deal. So we're gonna go to Desmos and, GeoGebra, and create an account. All right, so let's do that first. So here's Desmos, here's my abortive attempt to figure it out on my own, but we want GeoGebra. So geogebra.org. In order to create an account, you want to, there's no create an account button on the main screen. So you go to sign in. And then once you hit sign in, you'll see create an account as an option. So click on create an account, and you'll see a variety of different options that you can follow here. And so one of them is to connect it to Google. Another is to connect it to Office 365. And another is Microsoft. I'm still working on what the difference is there. I thought this was part of that, but maybe this is like your Xbox Live account. I don't know. I would stay away from Facebook and Twitter just because recently I've seen that a lot of apps and companies are trying to move away from the Facebook login because of security issues. So, so if you can link it to a Google or a Microsoft account, that would be probably the way to go. So I'll click on Google, show you what it looks like. Can't show you what it looks like because I already have a Google account. Let me do it incognito. Create an account, click on Google, And then it asks,
Are we
sorry?
supposed to see your screen right now? Because we can't.
Oh, because I'm incognito? Dang it. It opened a new browser. Let me see if I can do this. No, there's no way to do it. All right, I'd have to share a different screen. I guess I could. Let me do it that way. New incognito, stop share, start share, incognito, share. All right. Geogebra. Geogebra.com or org both bring you to the same place. So sign in, create an account, select the one that you want. I like Google. Human race, put in your credentials for Google. And then it'll say something like, do you really want to do this? Is it really you? And all that stuff. Where am I doing this? And way. Do it as a text message. And so this is the way I choose to do it. And I'll get to this point and it'll tell me I already have an account, but oh, actually it didn't. Right, so I'm in, I have an account, it populated it with all the information that I needed. So we're good to go there. Now it's a matter of actually doing the work. So now what I'm going to do is bring up the assignment, but I'm going to look at that in a separate screen. So you'll have to look at it on your own because I can't split screen within the same Zoom window. So that's one of the failings of this whole system. So I'll talk you through it, but if you have the file open, you should be able to follow along. All right. So if you maneuver your screen, you'll see that different, it takes on a different form. The smaller, like I'm doing a more minimal screen, and it makes it a more mobile look. But what we want to do is go to Geogebra Classic. So if you click on the waffle, you can see, so this the square thing, waffle, Geogebra Classic is one of the options. All right. There, you can get through it other ways. You can do it with Geogebra Graphing Calculator or whatever. I just find that the Classic is the one that glitches the least. All right. So the assignment is talking about time versus temperature. And time versus temperature is a really important thing when you think about the real world. Like, if you're going to make a prediction about weather, that's one thing that's going to be a component, like time throughout the day corresponding to temperature throughout the day, tidal waves throughout the, like wave height based off time, things of that nature for predictability. So there's a lot of stuff going on when you're talking about like physical phenomena and versus time. So we're just focusing on time versus temperature. So what we're going to do is take each entry that they have in the table, so all those times, 0, 2, 4, 6, 8, 10, 12, 14, and pop those in along with their corresponding temperature values of 94, 82.9, and so on, and they're automatically going to get plotted on the graph. All right, so I'm going to type in A equals 0, 94. So just as you see what in the handout, I just did a screenshot of what I typed in on Geogebra and put it in the handout. So what you see is what you get. So I type in A equals 0, 94 in parentheses. So B equals 2, 82.9. And then so on. So C equals 4, parentheses, gotta have the parentheses, 4, 73.6. D equals 65.7. 6 comma 65.7. I missed a 6. Double checking as we go. 8 comma 49 is E. F is 10 comma 53.3. Comma. G 12 comma 48.5. And H 14 comma 44.4. All right, so I got all these values in. I'm going to double check them, because that is the only, well, I don't want to say it's the only way you could screw this up, but it's the number one way. All right, so those points are in. Now what we want to do is come up with lines and curves that'll fit these data points. All right, this is one type of a statistical display that we're going to be working on. It's called a scatter plot, and also linear regression. All right, so we're going to be moving into that in the second half of this unit. And so it's pretty important that we get technology involved, because these are such a pain, not only to do by hand, but also to do by hand by computation, but also just to create the graphs. It's just very, very tedious, and there's a lot going on. So what we're going to do first is zoom out by rolling the mouse, or you can select the zoom out function until you see the points, and you can see a variety of them. So now what we're going to do is we're going to follow these processes that are listed in step 2. GeoGebra can be used to create different regression models. All right, regression models are just different functions, lines, parabolas, perhaps exponential functions that can fit a particular data set. All right, so we have, in this case, linear, polynomial, and exponential, and we have the commands that apply in those particular cases. So what the questions are asking us to do is create linear, second degree, and exponential regression. A second degree polynomial is just a quadratic, right? So what I would do is type in fit line. For some reason, you just got to scroll. Fit line. It brings up a bunch of commands at the bottom that you can click on. I gotta say that I've had more trouble. Well, I'll tell you that any trouble that I've had almost always comes from clicking on these commands at the bottom. Right? So when you start typing something, it brings up possibilities that you can click on. And almost always I screw it up, and so do my students when I do that. What I've kind of looked at these as is suggestions of what I should type. And I think if you go about it that way, you're probably going to be better off, but I'll let you be the judge, right? So I'm going to type in an open parentheses and then an open squiggly bracket. All right. So we got a bracket within a bracket. Squiggly bracket inside ordinary parentheses. The regular parentheses are to indicate that what is contained within these parentheses is going to be applying to the fit line function. The squiggly brackets are GeoGebra's way of knowing that what you're designating are specifically coordinates. All right. Now I have coordinates that are labeled A, B, C, D, all the way through H. So that's what I'm going to type in. A, comma, B, capitals. So the nomenclature is very important. So capital letters, because that's how they're represented in the list, right? If it was called lowercase a, then we would reference it as lowercase. So it matters if it's capital or not. So A, B, C, D, E, F, G, H. All right. double check to make sure you got your commas where they're supposed to be. Hit the right arrow all the way out. Make sure you're beyond the last closed paren, and then hit enter. And you'll see a couple of things happen. One, you now have a line that fits your data, or at least as best as it can. This is what we call the best fit line, right? It's the best possible line to fit these data points. And if you're familiar with concepts of college algebra, pre-calc, you know, that kind of stuff, then you might recognize this as a y equals mx plus b type equation, right? So this is the equation that fits these data points, all right? So we got what we were looking for that first step. That's the linear equation, right? Now, how does this help us? Well, on a test, I'm going to ask you to write the equation of the line that best fits the data set. Now, you might choose to use a graphing calculator or other resource, but you might also choose to use this technique. This is kind of forcing you to at least create a template of how this kind of thing would work going forward. So I'm going to pause because I see I have a question. So the next step in the process is to come up with what we call the coefficient of determination. And so the coefficient of determination represents the strength of the relationship between the points and the line, right? So it's a question of whether or not the line is going to be a good fit for the data points, right? So what we do is we type in r square. I have my cap locks on. R square. And just like we did for the previous computation, open paren, open squiggly bracket, and then type in A, comma, B, comma, C, comma, D, all the way to H, right? R. And then close them up and hit enter. Illegal arguments. I missed something. A, B, C. Oh, I did miss something. So after you finish your squiggly bracket, before you close them up, go outside the squiggly bracket. You got, this is an important part. We wouldn't know this yet because we haven't gotten to this part of the unit, but we have to tell it what line, because we told it where the points are. We have to tell it what line we're comparing it to. So after you close the squiggly brackets, comma, F, lowercase f, then go outside the ordinary parentheses and hit enter. And now you have the r square value, which is 0.92, right? It's like standard deviation in that it's a comparative value, but the closer it is to 1, the stronger the relationship, right? So it's a battle. We're going to come up with 3 different types of functions. One of them is going to have an r square that's closest to 1. The one that has an r square closest to 1 is the one that we're going to go with. All right, so let me pause. All right, so then next up in the process is the fit poly. I'm going to go through the typing part of this process again, but if you're careful enough, you see what I'm doing here is I'm trying to do a little copy paste, but you see like it gets a little finicky. I try to drag it over, but then it doesn't let me, and then it kind of lets me. It's kind of weird like that. So if you can get it, if you can lock onto it so that you can get at least the points and do a little control C action, that can save you a little bit of energy, but it's so weird. Like Desmos is so very easy when it comes to copying and pasting that it makes you think that this would be easy too. This is not as easy. So sometimes you just have to type it in again. So we're going to do fit poly. Open paren, open squiggles, and I'm going to just do a control V. That's going to bring my quote. You see, look what it did. It brought in everything except for the commas. So I got to go back and put in the commas anyway. So it really didn't do anything for me. So you see that the copy paste function kind of lets you down here. So A, comma, B, comma, C, comma, D, comma, E, comma, F, comma, G, comma, H. All right. So after the squiggles, what we're going to do, and you want to hit the, if you click out of it, it gives you a little bit of an issue, but you want to hit the right arrow. After the squiggle closes, you want to throw a (2) in there. Otherwise, GeoGebra will decide what the degree of the polynomial is going to be. I think it decided for mine it was going to be a 7th degree polynomial. I don't want that. I want a 2nd degree polynomial. So I'm going to put a (2) in there to indicate that it's a 2nd degree polynomial. All right. So then get out beyond the parentheses and hit enter. If you're ever in doubt, like you can't see enough of the screen, you can drag a little bit more so that you can see a little bit, but the interface is, it's a little clunky, so you just got to be patient with it. All right. Now, one little aspect of GeoGebra that is really nice, aside from actually doing the math for us, is that there is a duplicate function. All right. Oh, sorry, I lost my (2). I put it in the wrong place because I got out of whack here. It should be down here. Okay, there we go. All right, so there is a duplicate function. You see the 3 dots here? The 3 dots, if you click on the thing that you want to duplicate, it'll duplicate it into the very next available row, input row. So I need to do an R² for my G function, my G of X. So I'm going to hit 3 dots in this field. So the R², and we have a choice of duplicate input, duplicate output. They actually just changed this. It used to just be duplicate. So now you can actually duplicate just the answer if you want, but I want the input. I want the whole shebang. It'll copy it right down into the next available field. But this R², I now want it to point to the G function. I want it to point to G. So what I'm going to do is I'm going to change my F into a G, lowercase g, and then I'm going to hit enter, and it reports back the R² value. All right. Now there's some graph stuff going on here over off on the side, but right now we're just focusing on the computation. All right. So there's enough stuff going on here that we don't want to be bogged down or distracted by the graph part of it. So we're just going to keep on keeping on here. All right. So the next part of the process is to find a fit exponential. So we did fit line, fit poly. Now we're going to do fit exponential. So fit exp. Here you can see the little indicator is we just need a list of points. So squigglies, A, comma, B, comma, C, comma, D, comma, E, comma, F, comma, G, comma, H. I don't need any other trimmings besides that information, so I can go beyond the close paren, hit enter, and it'll give me the function. And we're not really interested in the function. I mean, that's an alarming looking function. That's scary. But I don't really care about that. I just wanted to come up with the curve on the graph, right? And then the R² is going to tell me just how good of a fit that curve is. Right, so I'm gonna duplicate my previous R². I'm gonna go to the 3 dots. I'm gonna hit duplicate input, and then I'm gonna change my G to an H because that's the name H of X. H is the name of the fit exponential function. So I'm gonna change that to an H. Hit the right arrow till I'm beyond the parens and hit enter, and we got the 0.95. All right. So we can perform some calculations with this stuff, all the stuff that we did, but what we want to do is draw a conclusion of, okay, well, which one's the winner? So now that I have this information, what I'm going to do is I'm going to go back and look at the graph now. And you can see there's a lot of stuff going on here. It's a big old mess, but we're going to parse through this mess and make some sense of it. So let me pause the recording, zoom the recording. So we have fit line, fit poly, and fit exponential, right? So we have the 3 possible functions. What we're going to do, and just a note on something here, this is the technology assignment. Like, I'm doing the whole thing for you right now. So all you have to do is reproduce what I'm doing, right? There's nothing beyond that. So like, you got to kind of imagine that this is a science class and this is a lab. What do you do in a lab? The professor outlines the lab, walks you through it, gives a demonstration, and then now here you go do. Right? That's what this is. So you're just carrying out this exact process. I'm not changing the numbers on you. It's literally these values all over again. It's just you're going to do it. All right. So yeah, this is not the hard part of the course. All right. So pause the recording. All right. So fit line has an R squared of 0.92. Fit poly has a 0.97, and fit exponential has a 0.95. The one that's closest to 1 is the one that we want, right? That's our winner. So we have our three possibilities. The one that has an R squared value that's closest to 1 is the one that we're going to call the winner. So 0.97 is the best one out of all of these, which means that this beats fit line and it beats fit exponential. So you see these little dots next to each function. These are, you think of them as the on-off switch. Right, so if I click on this, it'll turn off, on and off the function on the graph. Same deal here. So now I've gotten rid of a lot of the fluff. I'm looking at the curve out of the three possible choices, the curve that fits my data set the best. And that's the fit poly. All right. So now we have our winner. All right. So that's great news because we're getting rid of the fluff. We satisfied the requirements of the assignment. We did the work, but we're getting rid of the fluff. And that's also very meaningful, right? So now what we're gonna do is evaluate those functions. We're gonna do some math related to those functions, but we're not really gonna do the math, right? There is, in number 4, there's some suggestions about rounding. That's informational. It's up to you. If you find that the numbers aren't really displaying the right way, you can play with the rounding settings. But number 5 is evaluating a function in GeoGebra. So if I needed to, for example, figure out what f of 3 was, and that's what it says in number 5. The example is f of 3, hit enter. I'll type that in just to show you. If I type in f parentheses 3 and close parentheses, all right, this goes right back to college algebra where you're evaluating a function. All it's asking you to do, or all you're asking GeoGebra to do, is take the number 3 and plug it into the f function. Right? So here's my f function. F corresponds to this equation. All that command is telling GeoGebra to do. So this isn't even a GeoGebra command. This is an algebra command. It's telling GeoGebra replace the x with a 3 and simplify. All right. So that's something that you could do. That's just an example. So I'm going to get rid of that. We don't need it. That's not part of the assignment. It's just a quick heads up. All right. Now, the real question is, using the best fit model in number 5, the one with the best R squared value, which we just came up with, evaluate the function at x equals 10. So all you're going to do is type in g, because that's the winner was the g function, corresponded with an R squared of 0.97. That's this equation. We're going to type in g, open parens, the number 10, and that's it. All right. So contextually, what this means is that for a time of 10, you can expect, based off of this function, a temperature of 50.66. All right, so, all right.
I have a question.
Sure. All right. So next up in the process, GeoGebra can be used to solve a function for a particular value. Enter the command nsolve equals g of x equals 60. So you could type in nsolve, or you could just type in solve, but I'll show you nsolve. And then you just type in the equation that you want to solve. So what GeoGebra is doing here is it is determining any solutions to the equation where g of x is equal to 60. So if you think back to an algebra class, this is equivalent to taking the parabola equation, setting it equal to 60, and then solving for the value of x. All right. So that's pretty important when you think about how complicated some equations can be. It's pretty important to have a piece of technology that'll do this computation for you instantaneously, right? So it's doing the work. It's telling me, because again, our relationship is very easy to lose sight of this. Our relationship is between time and temperature. So when I set the equation equal to 60, I'm taking my function and setting it equal to a temperature of 60 degrees. This will tell me the time that it takes to be at a temperature of 60 degrees. Now, contextually, we're looking at the temperature in a bun t minutes after it's taken out of the oven. So this is telling me that about 7 minutes after it comes out of the oven and about 24 minutes after it comes out of the oven is when the temperature of the bun will be about 60 degrees. Right, so that's pretty meaningful stuff. I mean, maybe you're not interested in buns and ovens and stuff, but I'm sure you could think of a physical situation where you might want to know how long it's going to take for something to cool off. I mean, if you've ever eaten a Hot Pocket or taken a sip from a hot cup of coffee, you probably have experienced that. I don't know if you're going to solve an equation to figure that out, but there's definitely value to it. Looks like I got some chats coming in, so I'm going to commentary. So. If you have questions specific to the structure of the course, I guess, I suppose you could stay after class and we can talk about it. There's a lot of stuff on Blackboard that kind of spells out everything that you need to know, like where to find files, where to find videos and stuff like that. So you just need to look. I went over all of this, but you know, if you were out that day, I suppose it really is just a matter of clicking in and clicking around, and if something doesn't make sense, then send me a message. I don't know that that this is the time necessarily to talk about that, though. So the rest of the assignment is really just more of the same. So you can actually, from this point on, be able to handle it because you're going to type in a fresh set of data and then do a lot of the same stuff again with that fresh set of data, right? So I'll take you through that part of the process next class. But for now, what I want to do is show you how to save this work because you don't want to lose all of this stuff. Look at all this, right? So what you do is you click on the little hamburger bad boy here. I hit incognito for some reason. And then you see an option to save. Title it, Tech A. I'll call it time and temperature. So it's saving. It gives you a little indication that it's saving. It's saved successfully. Then you can, when you go to post it in Blackboard, you want to share a link. So you can click on the hamburger thing again, and then click on share, and you can see here that there's a share link. You can copy that. You can go into the assignment pane. So I'm going to stop that share and start this share again as soon as I find it. 1 second. We'll bring up Blackboard. Bringing up the Zoom. So in Blackboard under technology assignments, you have tech assignment A. If you click on it, you have a place to put your work, right? So you can see here for this one, writing your submission rather than uploading something is just fine because there isn't really much in the way of typing. So in write submission, all I would do is just paste in my link, and that's the first part of the assignment, all right? So you might even call it part 1. And then you would move on to part 2, which is it's still related to time and temperature, but in a different context. And then you could, once you finish that, you could submit, right? So there really, there is a learning curve involving GeoGebra, and it can be overwhelming, but if you take the time and really think about it, it's really not that bad, right? So, so I'm going to stop the share here. Actually, let me stop the recording first.